To prevent damage to the steam turbine during startup and other events, steam must be of a specific pressure and temperature. Bypass valves are used to properly set steam header pressure for each condition, including plant startup, plant shutdown, and steam turbine trip events. There are two basic turbine bypass valve designs. Both combine a pressure-reducing valve with a de-superheater in a single valve. The first is the flow-down design. Flow-down means the flow through the valve flows down through the seat ring to the valve outlet. These are the predominant design used in power plants constructed before 2003. They are most often installed with the actuator and valve outlet in the horizontal position because the inlet steam piping to the valve flows up vertically through the grating, and the outlet piping from the valve flows out horizontally. The horizontal actuator and trim installation make maintenance very difficult because overhead lifting devices cannot be used. The ability of a flow-down design to control aerodynamic noise is also quite limited. The design used predominantly since 2010 is the flow-up design. The flow-up design can be installed in the same piping configuration as the flow-down design, but because of the flow-up trim installed in the valve, the actuator and valve trim is in the vertical position. This makes performing maintenance much easier, as components can be lifted from above rather than the side. The flow-up design also allows the use of the various Fisher Whisper valve trims to provide noise attenuation through the entire operating range. In many cases, if there is sufficient headroom for the actuator, CVX valves can be converted to TBX valves for easier maintenance and better noise attenuation performance. If headroom does not allow for a standard TBX to be retrofitted, there are flow-down options that provide excellent noise attenuation by using a Sempel 115 or flow-down Fisher TBX. The de-superheating section is used to condition the steam exiting the bypass valve to meet the requirements of the downstream system. Feed water is supplied to nozzles via a spray valve and associated block valve spraying the water into the steam flow path. The water injected into the steam evaporates by absorbing heat from the superheated steam. The result is a reduced steam temperature. The following steam turbine bypass valves are utilized in this steam system. The high-pressure steam bypass valve controls the steam pressure from the high-pressure section of the heat recovery steam generator. The bypassed steam is directed to the cold reheat header back to the heat recovery steam generator reheater section. Along with the HP bypass valves, the steam plant will be equipped with a hot reheat bypass valve and a low-pressure steam bypass valve for each Hersig. These valves provide the same purpose for the hot reheat and low-pressure steam systems. The hot reheat and low-pressure bypass valves dump steam directly to the condenser. The high-pressure bypass valve has 3 different control modes depending on the status of the combustion turbine generator, or CTG, the heat recovery steam generator, or Hersig, and the steam turbine generator, or STG. Those are Startup Mode, STG Normal Mode, STG Trip Mode. During startup, the bypass valves will maintain a pressure set point necessary to roll up the steam turbine. The valves open and close as necessary throughout the startup. Also, during the blending process, when both steam plants are connected, the lag unit bypass valve set point is adjusted to match the running unit, equalizing the pressure across the header block valves, allowing them to open. The STG normal operation mode is active when the STG main steam control valve is open. The bypass valves are provided a floating set point of 20 to 30 psi above current header pressure, effectively driving the valves closed. The STG trip mode is automatically activated whenever the STG trip pulse signal is true. When the STG trip mode is activated, the DCS will position the high-pressure bypass valve to a calculated position to approximate the HP steam flow that existed before the trip occurred.